Hello guys, I am Paul McWhorter and I am here today with lesson number 23 on using the Arduino microcontroller. We have an exciting project today. It is an extension of lesson 22. What we're going to do today is we are going to create a GPS data tracker. And the way this works is that you've got a GPS. We are using the most excellent Adafruit Ultimate GPS connected to the Arduino, and we are using the VirtuaBotix SD card reader writer. And then we are going to power the whole thing with a dandy rechargeable battery. And so when we get this thing programmed up, we'll plug the battery in, walk around outside, and it will constantly be logging our position, our GPS coordinates, and then when we come back inside, we can take the SD card out, pop it into the computer, and we can see where we have been using Google Earth. And so this is a pretty exciting project, and we are going to jump right into it and get started. The first thing that you're going to need to get started, go ahead, and the easiest way to get this information is to go to toptechboy.com, my website, and when you go to that website you can look for Arduino lesson number 23. Okay, Arduino lesson number 23. And what you will need to do, you will need to connect up the GPS. Let's talk about where you can get this stuff. I've got links here of where you can get your Arduino, the Ultimate GPS, VirtuaBotix SD card reader, the battery clip, and the 9-volt battery system. Or you can hunt around and see where you can find this stuff. But these are the specific units that I'm using. Okay, you're going to need to hook your GPS up. 4 easy connections to get the GPS hooked up to the Arduino Uno. VN to 5 volts, ground to ground. RX to pin 2, RX to pin 2, and TX to pin 3. You'll also need to hook up your VirtuaBotix data logger, and you can use that as follows: ground to ground, ground from the SD card to ground. 3.3 volts is not used because we're going to connect with 5 volts. 5 volts to 5 volts, the CS chip select on the SD card to pin 4, MOSI on the SD card to pin 11, SCK to pin 13, MISO to pin 12 on the Arduino, and ground to ground. So there's a ground on both sides of this. Just to be safe, I hooked both of them up to the Arduino. Because you're powering a lot of stuff here, you probably need to create you a 5-volt rail here and a ground rail, and then just hook your 5 volts into here and hook your 5 volts into here and ground, and so that you have plenty of connections for ground and 5 volts because our circuit is starting to get pretty complicated. Okay, we need to go ahead and get that code that we developed in lesson 22, and if you haven't gone through lesson 22, you need to do that. You can go to toptechboy.com, go to Arduino lessons, come down, and you should see lesson number 22. And if you go to lesson number 22, you can catch right up to where we were. Here is the code. We can click this. And we can copy this code. You need to go in and develop this yourself, but I'm assuming you've already done that on lesson 22, so you can just jump right in what you had before. And then we start with a nice new Arduino development environment, and we come in and we paste our code from lesson 22. And if you remember what we ended up with on lesson 22, we just kind of got to the point that we could talk to the GPS, and then we were just sitting there and we were printing out our GPS. We were printing out our NEMA sentences, okay? And so just very simple, we were just printing out our NEMA sentences, and we could see that we were getting those NEMA sentences off of the GPS, and then we were printing them out. Yesterday, or on lesson 22, we didn't actually take the thing outside and walk around with it, because if we did that, there would be no way to see what the data looked like. So that's what we're going to do today. Today we can do that because we'll have the data logger and we'll have the battery where we can actually walk around outside. But there is a little code that we need to develop before we can do that. And mainly what we're going to be doing today is we're going to be taking the code from lesson 22 and we're going to be getting that that SD card working. I think it was in lesson 21 that we learned how to do the SD card reader, and so hopefully you already have your card reader, and hopefully you can recognize this stuff and in fact figure out most of it for yourself, since we have already kind of done most of this in our earlier lessons. Okay, so let's just jump in here and start doing our code. If we are going to use the SD card reader, we've got to load the SD library. The good news is the SD card library is already, it's something that comes with Arduino, so you don't have to install it, you just got to load it into this sketch. So we go load SDH or include SDH, and that is simple enough. Load the SD card library, right? We also, the SD card needs to use the SPIE, the Serial Peripheral Interface library, and that's just a way for sophisticated components to communicate to each other. And so we're talking between the SD card and the Arduino using SPI, which is a very useful protocol. Okay. Remember, in this unique case of loading our libraries, we don't put the semicolon. Okay, load the SPI library. Right. Remember that you've got to install this Adafruit library, and you can go back to the earlier, I think the previous lesson 22 to see how to install this library. So you can't just load this one because it doesn't come with the Arduino. You have to actually install that library. Lesson 22 will show you how to do that. Okay, we come down here. The rest of this looks pretty good. What we are going to need to do is define a few variables for using the SD card reader. If you remember, we have to tell it where our chip select is connected, and we connected the chip select to pin 4. Okay, chip select is connected to Arduino pin 4. Okay, and we have to have a file object because we have to treat this SD card reader as an object. So we have to have a file variable. And remember, we've done ints, we've done strings, we've done floats, and now we have a variable type of file, which is very good for interacting with files. And we're going to call it mySensorData. Okay, the file name that we're going to use is mySensorData. Okay, declare variable for reading or for your SD card object. Okay, so that's just a convenient way that we'll be able to write to that file and read from that file by having an object name that's of type file. Okay, so that's pretty good. Now we come down here and we are setting up our GPS, and we also need to, while we're in the void setup, we need to set up our SD card. And if you remember, there's some quirky things about this card, that it wants to have pin 10 reserved as an output and not used for anything else, even if we're not connecting to it. Must declare pin 10 an output to keep SD card reader happy. Okay, sometimes you just go with it whether it makes sense or not. Now we need to turn it on, so it's called SD because that's what the library is. We do an SD begin. Okay, and we want to do an SD begin, and we got to tell it where we're connected. Well, where are we connected? We are connected to chip select. Okay, so we've got to tell it chip select. And chip select is 4. I guess we could write 4 in here because we've got the chip select connected to 4, but it's just better practice to use our variables. Okay. So we initialize our SD card and say it is connected to chip select. All right, so that looks good. Let's see. There's a couple of things that we're going to have to jump right into here. What we want to do is remember that we're creating a file and we're writing the file here. And when we open a file on that SD card, if we open a file, if the file doesn't exist, it'll create it. But if it does exist, then it appends data to it. And the problem with that is that you end up with all the old data from your earlier experiments or your earlier walkings around. And so I want to just take a second here, and if the file is there on the SD card, I want to erase it. Okay, if the file is there, I want to erase it so that then I start with a clean, fresh file and I get rid of that old data. Okay, now this is a couple of new commands that we're going to learn. Is we can see if a file is there, and we can do that by saying if sd.exist. Okay, and well, what file are we looking for? We're going to hold our data in nmea.txt, right? And actually, we're going to have two data files. I always like to store my raw NEMA sentences, because if anything goofy ever happens, you can go back and look at those NEMA sentences and you can see your raw data. So I always like to have one file where I'm just dumping those NEMA sentences to. And so I'm checking to see if that NEMA.txt file is there. And if it is there, okay, I'm going to check to see if NEMA.txt is on SD card. If so, delete it. So this is the start of my if statement. Let me end my if statement so I don't forget to do that. So open curly bracket to start the if statement, close curly bracket to end it. And then what do I want to do inside that? Well, if it's there, I want to sd.remove it. And to make sure I get it in here right, I'm going to copy that, copy, and then I'm going to paste it like that. So if it's there, remove it. Okay, so that'll get rid of the old file. Now I said I had two files, so I want to do this for the second file as well. So I'm going to come down here and just copy and paste. So I take those three lines and I copy and paste. I'm going to do this for my second file. And my second file I'm going to have is GPS data.txt. gpsdata.txt, and I will copy and paste that. All right. And what I do is in this NEMA file, we're going to save the raw NEMA sentences, and in this file we're going to save our parsed GPS coordinates and elevation. So we'll have two different files. So I want to check and get rid of both of them before I move on. That looks pretty good. So we've got our things going there. Now we come down to our main loop, and we're going to read the GPS. And remember, this read GPS is a function that we created, and what it does is it goes in and it clears the GPS, and then it reads in two good sentences, and when it gets two good sentences, it pops back up here. So when we get to this line in the code, we should have two good GPS sentences, and they should be parsed because we parsed them as well, right? We said GPS parse, and so that once we parse them down here, then that opens up some new commands that we can do up here. But one of the things is that we don't want to do anything if we don't have a fix yet, and a fix just means that the GPS sees the satellites. The GPS sees the satellites and is getting good data, okay? And it'll spit out empty NEMA sentences, but we don't want to save any of that data until we get good GPS data or get a fix. And so what we do here is we're going to look and we're going to say if GPS.fix equals 1. So what happens is GPS.fix is going to be 0 until we get a fix, and once it gets a fix, then GPS.fix is equal to 1. And so we're checking if GPS.fix is equal to 1, then we're going to go and we're going to do all these following commands. And so let me go ahead and start my if statement, and really everything is going to be inside here because we don't want to save any of the data or do anything unless we have a fix. And so what this is going to do is, like right now, if you look at this red light blinking kind of on and off, that does not have a fix, and I don't have a fix because I'm inside and it can't see the satellites through the roof. But when you have a fix, this thing will just blink like once every 15 seconds. So when you walk outside, watch that red light, and when it just blinks once every 15 seconds, that tells you you have your fix. And then once it has the fix, then you want to log the data. Okay, so only log data after you have a fix. All right. So when I am here now, let me put a little white space in here. While I am here, I'm going to have a fix. And so what do I want to do if I have a fix? Well, I want to write the data to the SD card. So I'm going to open my first file, and we called this file that we're working with up here, the file type is going to be my sensor data. So I'm going to say my sensor data is going to be equal to, what do we need to do? We need to open the file, sd.open, and then we got to tell it what the file name is, NMEA, nema.txt. Okay, and remember that's the file that we erased up here, so we're going to be starting with a clean file. Now when you do an SD open and there is not that file name there, it'll create it. So even though you've erased it, it'll create it here the first time through. And then how do we want to open it? We want to write. So we're going to have a file write. And so that just tells it that when you open it, you want to open it for writing. Okay, so we're going to open nema.txt for writing. All right. So now that we have opened it, what do we want to do? We want to write those two sentences. Remember in the earlier lesson, when we do this GPS read, we get two GPS sentences, NMEA1 and NMEA2. One of those should be your RMC sentence, and the other one should be your GGA sentence. So we should have those two sentences, and we want to write them to the data file. So I'm going to say my sensor data, okay, dot print ln, because I just want one sentence per line, and then I'm going to print NMEA1, my first sentence. I'm going to write first sentence to the SD card. Okay, and then I'll just copy and paste this to make it easier. Control C, Control V, and then I'll write my second NMEA, my second NEMA sentence to the SD card. Okay, I've written those things. I've got to always remember to close my file. So I've got to close this file object out, .close, like that. Okay, close the file. All right. So that little bit of data right there is gonna write the data to the write the two NEMA sentences to the SD card. But in addition to that, what I'm going to want to do is, in addition to that, I also want to put the parsed data to a different file. And remember when we came down here and in our void GPS read, when we do a GPS read, we actually come down and we parse the data. We do a GPS.parse of the GPS last NEMA. And what that does is that opens up all these new commands in that library where I can just go out and I can grab things like grab the latitude, grab the longitude, grab the altitude. Okay, I can just go grab those things, and so that's very useful. So since I parsed it down here in the void read GPS function, I can come up here and I can just start writing new stuff to that other file. But if I'm going to write new stuff to that other file, the first thing I need to do is open it. So I need to do my sensor data dot my sensor data is equal to, let me make sure I spelled it right, my sensor data is equal to, I got to open the file again, sd.open, but I don't want to put it in this NEMA text file, I want to put it in a new file. And what I'm going to call that new file is GPS data.txt, like that. And how do I open it? I'm going to write. So I'm going to say file underscore write, because I want to open it for writing. Okay. And so what this is going to do is open the GPS data.txt file on SD card. Okay, I think that'll be good. Now that it's open, I can write it. So I'm going to say my sensor data dot print, and then I put in here what I want to print to it. Okay, and what the command I want, this is what I want to print. I want to print the latitude, and then the comma, and then the longitude. Okay, I get the latitude by getting GPS dot latitude. I get the longitude by GPS dot longitude. And then also one of the quirky things is that it's not just the latitude, the number, you also need to know which hemisphere you're in, north or south on latitude, and east or west on longitude. And so we need to print those things out as well. And so let's just start. First thing that we want is to print the GPS dot latitude. Okay, and what we got to be sure is that normally when you do a print, I think it gives you 2 decimal places. Well, that latitude number is going to have 4 decimal places, so I have to put the comma 4 there just to make sure that when it puts this on the SD card, I get all the data, that it doesn't truncate it, because on these GPS locations we want it to the very last decimal point. So we're going to write latitude to the GPS, to the GPS file. All right. Now my sensor data.print. We got to tell it which hemisphere it's in. So we do GPS dot, and to get the whether you're in the N or the on latitude, yeah, it's N or S. You just do LAT, and that'll be either an N or an S. Okay. Which hemisphere you are in, which will be an N or an S. Now we want to do my sensor. And notice how I'm putting this all on one line, because I'm doing prints, because I want this one, I want latitude, longitude, and altitude all on the same line. Data.print. And now I'm going to do GPS.longitude. Okay, and I want those 4 decimal points on that as well. Okay, so write longitude to the GPS file. Now my sensor data dot, still on the same line, print GPS.lon. And what that's going to be is that will either be an E or a W, okay, for east or west. And you need this information because when you go to put this stuff into Google Maps, it wants to see where you are, north or south, east or west. So, which hemisphere you are in, this is east or west, like that. Okay. I think I forgot to do something here. I forgot my comma. So after I do latitude and lat, I need a comma in there. Okay. After that, I need to do just a my sensor data dot print, and I need to print the comma, like that. Write a comma, and now I've got longitude and lon. Okay, and now I need another comma. My sensor data dot print, and now what I'm going to need is GPS ps.altitude. Okay, and that'll just pop that altitude right in there. Right altitude. Okay. Now, I've written all the things I need to write. What do I need to do? Hope you remembered it. Got to close the file. Believe me, you have more problems because you don't close your files. At least speaking of the students that I have, oftentimes forget to close their files. Close your file. All right. Okay, so let's look at this. I come up, I read the GPS. If I have a fix, then I want to write all of this data. I open my NEMA file, I write my 2 NEMA sentences, and I close my NEMA file. I open my GPS data file, I write my latitude, then which hemisphere I'm in, I write the comma, I write the longitude, I write the lon, which hemisphere I'm in, and ooh, I need a comma in there between those two. So I want a comma between my longitude and the altitude, so I forgot to print, and I need a comma. And also, when I get to this is the last thing on that line, and so I want to go to a new line, so I need to put the print ln there. Okay. So let's see if this thing is going to work here. Let's see if I made any mistakes. Let's go. No, I didn't mean to do that. Let's go like that. Oh, what is it not like? Ah, up here on this, I forgot my semicolon there. Did you guys catch that? Hopefully you did as I was going through it. Hopefully you were yelling at the top of your lungs at me to put my semicolon in there. Okay. So now it looks like it's going to compile. It looks like it's going to download. And let's hold our breath. I hope I don't have a serial monitor open. Yeah, I took it. Okay, so now if I look at the serial monitor, I think I should see, let's see, oh yeah, I have the print statement down in the, this isn't those writes we just did, but remember in that GPS read I had a print statement. And so we see an A and a C, 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 an A and a C. And so we're sitting here reading these NEMA sentences, and we are getting a good A and a good C, and all these look like good sentences, and so this all just looks really good. So I'm going to go ahead and close that. So now, guys, what's going to happen? I'm going to go outside and I'm going to walk around. So I'm going to unplug this from the computer. All right. The program's already down in it, so now I'm going to take my little 9-volt battery, and I will get this where you can see it, and then you see this right here? That is for plugging in the 9-volt battery. And then when I plug it in, what you can see is the Arduino has come back to life, and the GPS has come back to life, and I am completely mobile. I am free to roam around the area. So what I'm going to do is I'm going to run outside. I will pause the video, run outside, and then continue the video, and then we'll look at this data coming off of here. Right now, I don't have a fix, right, because that LED is blinking fast. I don't have a fix. The red LED is blinking. I don't have a fix. So there's no data being logged right now, but as soon as I go outside, it'll take about 30 seconds to get the fix, and then I'll walk around, and then we'll come back in and see if we can see that data. Okay, Okay, I am back, and I have been outside walking around, brought the unit back in. You can see that we were operating on battery power alone, and what I've done is I've popped the SD card out. I can stick it over in the computer, and let's open that SD card up and see what we can see in there. Give me just a second here so I can pop it open, and what we can see is that there's 2 files, and it's the 2 files we created, NEMEA.txt and GPSdata.txt. This one should just have the NEMA sentences. Let's take a look at it. We pop it open, and sure enough, this is the the RMC sentence and the GGA sentence, RMC, GGA, and so we're sitting there and we're grabbing one of each type of sentence and we're dumping it here to the SD card. If you can remember in our previous lesson, Our NEMA sentences were empty. They had a bunch of commas and zeros. And you can see here when we went outside and actually got a fix, we're now getting data. This represents the time. 3051.7880 north is our latitude, and then our longitude, and it shows that we're in the northern hemisphere, the western hemisphere. And so there's all types of useful data in here. But this data is kind of hard to read. We just like to keep kind of the raw data. The better data should be in our gpsdata.txt file. And if we open that, look at that. We have latitude and then northern hemisphere, comma, longitude, and we're in the western hemisphere. And look at that, our altitude in meters. And so let's check that altitude and see how that looks. It says that I'm at 779 meters, and so what I can do is I can come over here and I can say 779 meters in feet, and that's saying that I'm at an altitude of 2555.77, which is very close to what my known altitude is at this location. So this is really neat. I went outside and walked around a little bit and I got these sets of coordinates. But how could we use these coordinates in Google Earth? So let's open up our Google Earth. It takes it a second to get open. And I think I'll close that and then get this the nice size where you can see it. Okay, so let's call back this. And of course right now we don't want to be putting altitude in there. We're not quite ready to do that yet, but let's just get these two. Okay, so I'm getting the latitude and the longitude. I come up here to Google Earth and I paste it in and I say search, and it says I don't understand this. Okay, and I'll explain to you why you don't understand it. That the way this comes out of the NEMA sentence is the 30 represents degrees, and then the 51.793 is minutes. So it's 30 degrees, 51 minutes, 51.7937 minutes in the northern hemisphere. This would be 100 degrees and 36 minutes. So when you find the decimal point, and 2 to the left of the decimal point is minutes, so that's 36.0273 minutes and 100 degrees. And Google doesn't understand this nice long thing here. It wants to see a space. And so that looks to Google like 30 degrees, 51.7937 minutes. And similarly here, the 2 by the decimal point are the minutes. So I come over here, and this is 100 degrees. So it's always 2 to the left of the decimal. 2 to the left of the decimal, and then I had 100. 2 to the left of the decimal, and then I had 30. And now let's put search, and look at that. It looks like it's coming to Texas. It looks like it's coming to my location here. And if I zoom in, this is exactly where I went to walk around. Now let's see, exactly where am I here? I am right here. I mean, this is actually where I am. I'm in this building, the school, and I came out. And I came over here to stand in the shade, and I rested in the shade for about 45 seconds while it was getting a fix. And then I started walking around. And so let's see if we can see me walking around. I don't want the altitude, so I'll just copy this, and then I'll come in. I'll paste it, and remember 2 to the left of the decimal. Oops. So that's 30 degrees, 51. 2 to the left of the decimal, 100. Okay, and you can see I got here and I started walking around the courtyard a little bit. Let's come down and get one of the later ones. And what it should be is I should just be kind of continuing to walk around in the courtyard. So copy. Okay, and then you can see what I did was I walked from there back to the back door, and then I went back in, and then once I went back in, it lost the fix because the ceiling, the GPS can't see it. So this is just really neat. We now have a device that we can walk around with, and it will log our position as long as this little GPS has a clear view of the sky. And I think this is just really, really slick. We can come back and then we can plug those coordinates into Google, and we can see Google Earth, and we can see where we were. This is just really, really, really neat. But I'll tell you what I hope is, I hope you will come back for the next lesson, which I think the next lesson is going to be like lesson 24 already. Yeah, let's see. This has been, we are presently on lesson 23. And so if you come back for lesson 24, what I'm going to do is I'm going to show you that, kind of like the little bit slow thing about this was we have this data file that has all of these coordinates in it. What I'd like to do is I'd like to take that data file and show you how you can generate a track where you can just go to Google Earth and you can import that, and then you can see your whole, basically your whole track. And so that's what we're going to do next week. Thanks a lot for tuning in, and we will see you guys shortly.